Uh, my name is Andrew Lamb. I'm the PMC chair of Apache DataFusion. I'm a staff engineer at Influx, and I am going to give you a brief introduction to what DataFusion is because I don't necessarily, I know some of you are intimately familiar and some of you are not. So I just figured I'd give you my high level overview, including basically use cases. So DataFusion is an Apache software foundation project. You can find all the deets here. I'll share all these slides and we're recording stuff. So with since I have to rip through this stuff, we're going to go through quick. What is DataFusion? So I'll start with what it's not. DataFusion is not, so like a typical app, the databases that you're used to, you would have your application, then you have a database, and then it has some particular choice of how it stores data and how it runs queries. And they made some choices in the design space, right? So DuckDB would be an example, or ClickHouse or something like that. And so people built database applications for 40 years. Like it works great. But basically you have to take what the database designer chose in that box, right? That's the key here, right? What is, you can maybe set some configuration parameters, but what's in the box you're using. And it works great for a lot of use cases. I think, however, there is an emerging class of systems that you'll hear a lot about from the other speakers tonight, where you want much more control. If you want more control, right? You didn't like the particular design trade-offs that an existing database system made. You can then use DataFusion and pick which parts you want to spend time optimizing. Right, so basically it's designed to be pluggable and extendable in basically any way. So you can then have much more control over your system. So I actually really like this example from someone, which is basically if you want to build a custom data system, what are your options, right? Your first option is you embed an entire system, right? Or you use a system like DuckDB or SQLite. Those are actually great. There's lots of examples where that's fine and it works really well, but you're basically more or less restricted to what the API service already is. Another option is you can take an open source database, which most of the popular ones are, and you can fork it, right, and keep your own modifications. The challenge with that is, and there's several people, I'm not sure if they're in this room, but certainly several people on DataFusion that have tried this approach and they've eventually gone back. And the challenge is maintaining that fork over the long term as upstream changes is really, really challenging. Typically, if you want to make deep changes to your database. And the third one, of course, you can build query engines from scratch. You can definitely do that, but it takes a long time. It's very expensive. I've actually done that. It took us like 4 years and 20 engineers to do it at Vertica, just to give you some sense, right? So it's not impossible. It's well understood. So, and of course, with DataFusion, the whole point is now you can start much faster with something that's working and then extend it wherever you want, and not spend time re-implementing something that's well understood. I'm definitely not going to read this whole slide, but the idea here is that it's well full featured. I've talked about this. If you know what databases and database internals are, like this is the kind of stuff you'd want. It has a very fast OLAP engine, and it has the ecosystem extension points. It has a full SQL optimizer, right, which is major. You can read and write Substrate. You can read and write popular data formats like Parquet, JSON, CSV, all that sort of stuff. It has all the goodies basically, but you can also extend it. I think the other thing that DataFusion has that's kind of cool that's been growing is a third-party ecosystem. So, it's all open source, but it sort of fits in this modular database world here where if you want a database system, right, in particular properties, you don't have to then just accept what people have already chosen. You can sort of assemble what you want out of custom pieces. So here's an example of additional pieces that people have offered in the open source community. For example, DataFusion Distributed has been showing up a lot recently. So that's distributed pieces for building distributed database engines. DataFusion is just a single node engine. We've also got things like table providers that have all the standard interfaces to talk to MySQL and ClickHouse or whatever. I think we have Luke and his team to thank for that, actually. There's also packages to help federated queries, packages to hook into distributed tracing, packages to make it work with geospatial data, and hopefully there's more and more. I don't know if you guys are into it. If you hang around with database people long enough, everyone's really into performance, especially analytic database. So the point is, DataFusion, in my opinion, is converging to the fast. We were the fastest at ClickBench for a while. Then the DuckDB guys spent 6 months and optimized it, and now they're the fastest. But over time, you can see, we're getting closer. So it started at 2. Now we're at 1.1. Most recent is 1.4, and the next release, I'm hoping, will be back on top. But so the point is, you don't have to be a bunch of database geniuses from the Netherlands to make a really to get access to a really fast database. And you have a lot more control over this one. All right, so my aspiration for DataFusion is, I love giving this example. It's totally geeky, but you'll have to bear with me here. Some people really love it, some people don't, but regardless. So yeah, you have to understand, like back when I started working in computers, there was basically GCC. There were proprietary ones too, like ICC, whatever. But basically, C++ was the thing, and there was not a lot of innovation in programming languages until about 20 years ago, well, 10 years ago or so. And I think the major thing that happened was that previous to this thing called LLVM, which we'll talk about, if you wanted to build a whole new programming language, you had to build obviously the front end of the language, but then you also had to build all the lower level pieces that were approximately the same. So you needed a debugger, you need debugger integration, you needed a fast code generator, you needed all the optimizations. And so I think the fact that this piece of software called LLVM came around, and now it basically enabled the explosion in computer programming languages that we've seen, basically the renaissance in the last 10 years, like Rust, Julia, Swift. You basically name any modern programming language, it almost certainly has LLVM under the covers. Now, why is that? It's basically because instead of having to reinvent all of the whole stack, which is basically the same, right? At least a lot of it's the same down below. Instead, those language designers can focus on what makes their language unique, and then they get access to the same fast underlying infrastructure for writing the programs, right? So with that hopefully long-winded explanation, you can imagine, I imagine DataFusion is the same story, right? Where if you're going to build high-performance custom analytic applications and data engines, instead of having to reinvent the whole thing from SQL parser to planner to query to whatever, instead you can start with DataFusion, build it on there, and then focus most of your time and effort on the features that matter for your application. I think we'll hear about a bunch of examples of that from some of the other speakers tonight, but this is the idea for me. So in my opinion, like in some ways you can look at this picture and it's basically like a cost story, like, well, it's just cheaper to build this stuff because, you know, now you don't have to build it yourself, right? That's one way of looking at it. I like looking at it a little bit differently, which is there's a lot of applications that are now actually possible. They're actually feasible to build because you don't have to rebuild the whole thing from the top, right? The features are better, and you're actually able to create innovative new products that you wouldn't have been able to before because it just would have been cost expensive, or they would have just been crappy performance or not featureful, right? So in my mind, yes, it's a cost story. Yes, it lowers cost, but it also really enables innovation and fun new applications. So that's basically what I hope it is. All right. I had to put at least one architecture slide on, then we'll rip through some other stuff. If you've ever seen inside of a database, this is what it looks like. It's got front ends. It has a full SQL engine, has a data frame API. You can basically, but for example, you can plug in your own programming, own query language. I know at least 2 people in this room have done that. Then it also has a logical plan. You can plug stuff in, physical plans, operators. I don't have time to go into this. You can watch, there's like multiple YouTube videos about how all this stuff works. But the point is there's blue boxes everywhere, right? And the blue boxes basically are where you can plug in and extend the system. It's everywhere. And it's designed for that, right? So it's not designed to be forked or whatever. You can sit there. All right, so now I want to talk, because I have 7 minutes left. I'm going to rip through, talk briefly about community, right? What does it actually mean? So there are 1,000 rather distinct contributors. It's probably more like 800 if you deal with the tortured Git history, but that's a lot of individuals who've contributed to this thing over the course of the years. We currently have 22 people on the sort of governance committee. Several of them are in this room, actually. 56 people with write access. And of our most recent release, we do releases approximately once a month. There were 114 distinct people who contributed to that. So those numbers are fun, but the point is not just like 3 people, and it's not one company just cranking around on this. This is quite a lot of people who have been using it for quite a while, and we continue to grow. One of the fascinating things, it's not like a company is just driving it. Obviously, companies pay people who help drive it, but we don't really have anyone that I know is paid to work full-time on it. So basically the people working on it are the people who are using it, which I think aligns all the incentives, right? Although of course it always means, and this is part of why I'm here, right? We always need more help because we always could use more time and effort. And the people who choose where we're going to head are the people who contribute in the time, because there's not people contributing money directly. So yeah, I'm not going to spend too much on that. I do want to say, actually, I was just talking to someone earlier. once upon a time, there was very few places in the world where if you wanted to work on database internals, you'd actually have a chance to. You'd have to like move to the couple of places that had companies that did this stuff. And now the fact that there's big open source projects, if you happen to be interested in this, and there are certain subsets of people, perhaps some people in this room that like really love this kind of low level stuff, it's actually kind of fun to have a whole bunch of people that you can come and find and work with us, and you don't have to like live in a place. Well, Seattle had a pretty good database, so maybe it's not relevant for the people in this audience. Anyway, so please come help us, right? That's basically the conclusion. All right, let me talk briefly about what the ASF is, Apache Software Foundation. DataFusion's part of this. I think it's basically a huge part of why DataFusion has been adopted so widely, and I'll try to explain what it is. So basically the core is, at the end of the day, it's predictability. Right? If you're gonna use and try to build an application on top of a piece of a software library, the last thing you want is like the license to change on you when the VC funding dries up or they need to get their money back or whatever. Because DataFusion is part of the Apache Software Foundation, you basically get it super predictable, right? The license is not gonna change, and there's basically no chance of it because of how the governance is set up. There's also, as with all other Apache Software Foundation projects, the communication is totally open. That sometimes means there's a fire hose and it's not like hard to figure out what's going on, but it is all open. There's not like conversations happening behind closed doors. And it's actually been very effective at getting companies to work together. Like there's quite a few companies that more or less you could, if you don't have to squint very hard, look very much like competitors to Influx Data that all basically contribute and use the same underlying engine. So anyway, that's it. The conclusion from my perspective is it's worked way better than I ever would have expected because I've not been in enterprise software for 23 years, something like that, 24. And I had no idea that this would work, but it did. All right, so now I want to spend the rest of my few minutes here talking about use cases, what people actually do with this system, because I think I used to really struggle with these slides because there weren't that many people who had used DataFusion in real systems, but now I'm probably not going to be able to get through them all. So the first case you can probably imagine is specialized databases. So that's like Influx Data, the company I work for, has a specialized time series engine, but there's a whole bunch of other examples. GrepTime actually is also here. There's a whole bunch of examples of like if you pick a particular area and you want a database that's focused on that, it's part of this longer term trend for the last 20 years of not just general purpose systems, but you build specialized systems for a particular use case. So you can use DataFusion for that. Lots of people do. I think another thing, probably the biggest use cases for specialized data systems. Once companies get to be a certain size, they tend to have their own like data platform teams. And those data platform teams have built some sort of infrastructure and bespoke systems that is optimized for their workflow. And oftentimes they want to be able to have more control over not just run ClickHouse, right? But like control what file formats and the caching layers and how the catalog works and all that sort of stuff. And so we see a lot of people use DataFusion as the core of that. Another fascinating thing I think that someone pointed out to me recently is I didn't appreciate this at first, but a lot of people, there's a lot of existing data platforms. And so unlike another type of database where you might have to like basically move your entire workload over to the new database if you want to switch it out, because DataFusion is modular, a lot of people will actually they can basically start introducing DataFusion at the edges and work their way in. So we've seen a bunch of people basically they'll like replace the low-level scan, say the Parquet reader, for example, with the DataFusion, and then they'll start moving up with the filtering and then maybe the aggregation, but they don't have to do it all in one big go. And so I think that's actually been, that's been pretty common, and I didn't appreciate how, the modularity actually would help people incrementally migrate, which is interesting. Another thing we've seen, although now Luke tells me this maybe isn't their focus so much anymore, is federated databases. So that's like if you want to write something which looks like a unified data view, but actually the underlying data comes from multiple other databases. You can build stuff like that with DataFusion. Now there are special other systems like Trino or whatever that specialize in that. But if you have other specialized use cases, you can certainly use DataFusion to do this. And you saw there's a bunch of pre-built like integration libraries for other systems. And it like has, for example, if you want to build a federated database, one thing you might want to do is push filters down into the other databases. And in order to do that, you need to like translate from one dialect into whatever dialect of the target system. So like DataFusion has that sort of mechanisms in there, which isn't impossible to build, but it's just sort of like a pain to write yourself and maintain. Another thing we've seen people use a lot is for DataFusion's Apache Spark accelerators. I don't want to harp too much on this given the host company that we're currently here, but basically, the open source Apache Spark engine is not super fast. There's a variety of vendors that can sell you a fast one, but there's also a bunch of people trying to make fast ones open source. So at least two of them that I know have been using DataFusion as the sort of native engines. So that's Comet and Oron. We also have a bunch of people using DataFusion for table formats. The last time I checked, it was the trifecta of the major table formats all use DataFusion in the Rust implementation. And why is that? Well, that's because table formats, while it might sound like it's just some sort of metadata that goes over files, which it is, you also have a bunch of operations like merge little files together or apply delete predicates, which starts sounding a lot like you need a query engine, right? Like you got to like read data and merge them, or you've got to actually evaluate expressions against large amounts of data. So you need basically a query engine to implement a bunch of those features, and DataFusion gets used for that a bunch. We've seen a bunch of people doing academic research on it, which is cool. You can read all about that. I'm especially proud that people from TUM, who are like hardcore C++ people, some of their grad students want to leave the C++ wagon, go on to Rust, and so they actually wrote some of their master's theses with DataFusion. We've also seen people put this in visualization tools. So like you might think visualization tools don't tend to have data engines, but they actually often do because in order to get fast driving around, you're basically doing slicing and dicing, aggregating and stuff. All right, I'm basically almost out of time. The other thing that we've seen people do is use them for table file formats. I won't go into that. The final one that I actually thought was fascinating is SQL analysis. So this is not something I ever would have predicted. But instead of using the execution engine DataFusion, they use the front end. They parse it, they turn it into logical plans, and then they do some sort of basically syntactic or semantic analysis on those plans of what they do. So oftentimes that's like with big complicated flows of SQL, you're trying to figure out what comes out the other end. Like for example, did personally identifiable information go into generating this? You know, you can actually use the DataFusion instructions for that. So anyway, that's yeah, I'm not going to rip through this. So anyway, with that, thank you very much. We're going to talk the next one. So thank you. And I think next up is Scott from Databricks, and we'll see how well this works.